Okay, so welcome back. This is the second class for the live tables and third class in our overall classes which we have going on apart from the orientation. And now on, in this class what we'll be discussing is nothing but a build up of what we had done in the previous class. In the previous class we had done about the live table functions, but now we'll be discussing more complicated concepts on the live table functions. So in the previous class, our case was very simple. We just had to figure out what 5p20 was and we were done with it. But what if, obviously this by the way, this is equal to L25 by L20. We already know that. We have already dealt with questions far tougher than this, so we already know how to deal with these kinds of questions now. But what if instead of asking us 5p20, in the question they asked us what would be the answer to 0.5p20? So they are gone into the non-integer area. Now the answer should be L20.5 divided by L20. L20.5 by L20. This should seem very simple, right? This should be very easy, right? But the problem is that it is not necessary. This was the live table, by the way, which we were dealing with earlier. Right? So in the previous class we had seen the data that is provided to us is not presented in that format. We needed L20.5, but we do not have L20.5. We have L20, we have L21, but we do not have L20.5. So that is the major problem here. How do we figure out what L20.5 would be? Now, the answer to L20.5 would depend on the kind of assumption which you are making. Now, there are different assumptions which you can make. Ultimately, you just have to go from L20 to L21, which should not be very difficult, right? Because ideally, let us say that L20 is equal to 2400 for simplicity and L21 is equal to 1200 for simplicity. Now we have to go from 2400 to 1200. So if I were to make a graph, let's say this is LH and this is my AH, then this would be 2400 and this would be 1200, right? I just have to go from 2400 to 1200, right? This should be very easy. We can just make a line and we can do that, right? But the problem arises that this is a very simple assumption. What about the countries where you have harsher winters, basically the areas wherein you have more number of people dying off in the later part of the year as compared to the first part of the year? So basically, as let us take the example of Darjeeling or Sikkim, or maybe Kanchenjunga, or maybe Himalayas, where you have very harsh winters. In those areas, the number of people who would die in the later part of the year would obviously be more than the number of people dying in the first half of the year. Now, what if I take an example of a place where you have very harsh summer, like for example Ladakh, like example Gujarat, or let us take the example of maybe Africa. The number of people who would die in the first half of the year would be more than the number of people dying in the second half of the year, right? So you can have different assumptions, you can have different functionality, different progress from 2400 to 1200 depending on where you are living in. But not to worry about. In this paper, you won't go too much in detail about these complex concepts. You can just simply make an assumption that number of people dying in the first half of the year is equal to number of people dying in the second half of the year. But it was my responsibility to tell you about the other assumption as well. So I have just told you. So as I said, the first assumption, which you will have to make here is that you can just draw a simple straight line from 2400 to 1200 and you would be done. But I just want to say that you can also have different assumptions. Like as I said, if you remember the example of Antarctica or Ladakh, Sikkim. So the number of people dying in the second half of the year is more than the number of people dying in the first half of the year. Then I gave the example of Rajasthan. Then number of people dying in the first half of the year is more than the number of people dying in the second half of the year, right? So you can have different assumptions. That is just what I wanted to point out from this example. But don't worry, you won't have to go too much in detail about this. You can just make a simple assumption that number of people dying in first half is equal to number of people dying in the second half. Or you can finally break it down as number of people dying in the first month is equal to number of people dying in the second month, and so on and so forth. Or in other words, I can say number of deaths in each month is constant. So basically, if I were to go from 2400 to 1200, essentially 100 people have died in January and 100 people have died in February, and so on and so forth. Okay, so that is what it essentially means. The number of people who are dying is basically constant. Okay, so this is what this assumption essentially means. Okay, now what does this assumption finally imply? This assumption finally imply that LH plus T is equal to T LH plus 1 minus T LH, or there is a second as implication for this as well, which is a very popular implication, which is obviously what I use normally, which is TQH is equal to T into QH. Okay, so these are the two assumptions, these are the two implications of the UDD, or the uniform distribution of death assumption, which you have made. Now, we do not have that much amount of time in this class to go in detail about how we have arrived at this, but in my full class, obviously I have gone too much in detail about how we have arrived at this. I have shown you this proof step by step, so you should just refer back to that particular class and you would be good to go. Obviously, next up, so as I said, that there are a different assumption which you can make, but one of the broad heading was uniform distribution of death. Another broad heading assumption which you can make is CFM, which is constant force of mortality. Now I know I have not discussed what force of mortality essentially means, but again, we cannot go too much in detail about all those technicalities in these classes. So I will just go directly into the conclusion of what CFM essentially means. So CFM assumption essentially means that you have TPH is equal to PH whole to the power T. So let me just give a quick example of what it essentially means. So if I were to refer back to my UDD problem, let us say if we were asked to calculate what would be the answer of 0.5 P20. So my answer for 0.5 P20 for UDD would be 1 minus 0.5 Q20, which is equal to 1 minus 0.5 into Q20. This is what the implication of UDD would have been. But let us say if I were making the assumption of CFM, which is the constant force of mortality, which is the second assumption which you can make, or if you already know what is the concept of force of mortality, we basically assume that force of mortality is constant, or basically the instantaneous force which is applicable on each and every one of us at every single nanosecond, that is assumed to be constant. So the implication of that would have been 0.5 P20 would have been equal to P20 whole to the power 0.5. So these are the two major implications which we have out of the assumption that we have made. Now there is a third assumption as well, third broad heading as well, which is de Moivre's law, again which I would be dealing with in my full class and not in this class. Okay, so let us just copy this down. I hope you can just quickly pause the video and copy this entire part down, because I will be dealing with some questions on UDD and CFM. Again, we'll be referring back to a new life table which has been provided to us, and we have to calculate what would be the answer for 0.26 P61, which should be very easy for you now because we have already done a question on this. Now making the assumption of UDD, I can write that this is equal to 0.26. I can write this as 1 minus 0.26 Q61, which is equal to 1 minus 0.26 into Q61, which is equal to 1 minus 0.26. Q61 essentially means that I am a part of these policyholders. So in denominator I will have 99,700, and I want to die within the next year. So I want to be a part of these 400 people. So this will be this. So 1 minus 0.26 multiplied by 400 by 99,700, and solving this I will get my answer. Okay. Okay, now let us say if I were to try this exact same question using the CFM assumption, then I would have done this as P61 whole to the power 0.26. So I can write this as P61 whole to the power 0.26. P61 essentially means L62 by L61. So I am a part of 99,700. I want to be a part of 99,300 whole to the power 0.26, and solving this I will get my answer. Now if you are solving a very simple problem like this, you might get similar answers. So do not be confused that what is the implication, why are we making two different assumptions when we are getting the same answer and all that. Do not worry about that. The reason why we are solving this simple question is so that you get an idea about the concepts which we are dealing with. Ultimately, you will deal with questions wherein you will get different answers, and ideally you are not supposed to get very different answers out of the two questions which you are dealing with. Okay, so do not worry about that, because again both of them are just simple assumptions which were built on reasonable grounds, which we have already discussed. And yeah, the difference between the two answers which you are getting won't be unreasonably very high. It is going to be within tolerance level. It is going to be within a reasonable tolerance level. So do not worry about that. Okay, so this is it for this class. We'll meet again in the next class, and we'll be dealing with a new topic after this. Thank you. Happy learning.